So number 1 and number 2 were just those formulas. The formula for the sum total of the interior angles, n minus 2 times 180, and the total of the exterior angles on any n-sided polygon, 360 degrees. Number 3, I started out by finding the sum of all 6 interior angles. So that was 6 minus 2 times 180, which is 720. Now I found that 599 degrees had already been used up on those 5 given angles. So the x plus that total of 599 had to total 720. So if you take 720 and you subtract off all those angles, you get 121 degrees for x. Number 4, again, I started out by finding the total of all 10 angles. 10 minus 2 times 180 is 1440 total for all 10. And this time all the angles are equal. It's a regular decagon, so I just took the 1440 divided by 10, and that makes 144 degrees each, so x is 144. Number 5, I was able to fill in the 15 and the 8, knowing that the opposite sides are congruent on a parallelogram. I filled in the 122 because the opposite angles are congruent. Now the 58s, I had to do that little trick about supplementary. You know how consecutive angles have to add up to 180? So I just took 180 minus 122, and that's 58. And then both of those opposite angles would be 58 degrees. Just to double check, if you want to add up all 4 of those angles, it should total 360 total. Number 6, I started with the sides. We had the 31 on top and 21 on the side because opposite sides are congruent. And then I had those crisscross diagonals. The diagonals bisect each other. That means this middle spot is a midpoint for both segments. So 11 right here means 11 right here, and 24 right here means 24 right here. That's what it means for diagonals to bisect each other. Number 7, hopefully you could remember all 5 of these without checking your notes. It helps me to remember that the first 2 are about opposite sides, the second 2 are about angles, and the last one is about those diagonals. Not that you have to have them in the same order as me, but opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles supplementary, and then diagonals bisect each other. That's an easy one to forget about. I said number 8 was definitely a parallelogram because both pairs of opposite sides were congruent. At first on the second one I was going to say no because I didn't have both pairs of opposite angles congruent, but then I did a little math. 4 minus 2 times 180 makes all 4 of those angles, they have to add up to 360 on any quadrilateral. So I took 360 and subtracted off the 3 angles I knew, and guess what? That missing angle has to be 65 degrees, and that would mean that both pairs of opposite angles are congruent, so that one was a yes. It just took me a little bit more work. The next one, it looked so promising. I saw those congruent angles, so I saw that backwards Z shape. Those congruent angles up in those corners, alternate interior angles, meant that I had parallel lines. But one pair of parallel lines isn't enough, so then I was hoping to see if I could find the other set parallel, or if I could figure out if the lengths were congruent, and I couldn't get any further with that, so I had to go with no, because I only had one pair of opposite sides parallel. In fact, I was able to even draw it a little differently, where it definitely doesn't look like a parallelogram. These 2 sides don't look parallel at all, but I was still able to keep those vertical angles congruent in the middle. I guess vertical angles are always congruent. And then these congruent did make my top and bottom parallel, but again, that's only one pair of parallels, which wasn't enough to say that's a parallelogram. I wonder if you got this one. It's a yes, because we have one pair of opposite sides that are parallel and congruent. It was kind of given that they were congruent with the 5 and the 5, but then again we had sort of that Z shape made with those alternate interior angles being congruent, which told me that those 2 sides were also parallel. So that's the one where we have just one pair of opposite sides are parallel and congruent. This last one should have reminded you of something we just did in another practice quiz. So hopefully you were able to replicate that. Did you decide to find the slopes of all 4 sides? That would have been enough. Or the lengths of all 4 sides? That would have been enough. Or the slope and the length of just one pair of sides? That would have been fine too. Remember that I'll be looking for those numbers, either the slopes or the lengths or both. And then it's nice to include that statement at the bottom explaining what did you just find out.